In Module 6.5, we're now going to be dealing with operations with radical expressions. And so, of course, radical expressions are square roots, cube roots, anything like that, or a to the half power, b to the 1/3 power, or to the 2/3 power. But anything like that is considered a radical expression. So the first thing that we need to kind of come to terms with are these things called like terms. And like terms when we're dealing with radicals means, for example, if I have the square root of x, in this particular case, a like term would also be square root of x. So if I have 3 square root, and of course normally we don't write the 2 there normally, plus 5 square root of x, these are called like terms because the variable x to the 1/2 power in both cases is my like term, and that means I can combine those together to become 8 square root of x. And right now, again, I'm writing that 2 there, even though we don't normally write the 2 there, but just to kind of emphasize that it doesn't matter what number's there. As long as these are exactly the same, then I can combine them together. Now, of course, that means that if I have 3 cube root of x plus 4 cube root of 2x, I could not combine those two together. So they have to be exactly alike for me to be able to add them or subtract them. And multiplication has a different property, and we'll get into that as we kind of go through. But these are what they're talking about with like terms. And then conjugates, if you recall, something like this, we used to have 3 minus 2i, and a conjugate for 3 minus 2i would be 3 plus 2i. So we have conjugates that we're dealing with that we can utilize to be able to a lot of times eliminate that I term in this particular case. And then we do the same thing with these radicals. So if I have 3 plus the square root of 5, its conjugate would be 3 minus the square root of 5. And what would happen is when I multiply these out, FOILed them out, or boxed them out, or distributed them, whichever way that you think about this middle term, there would be no square root of 5 left, because we'd have 3 times 3, and then 3 times negative square root of 5, 3 times positive square root of 5, which would cancel those out, and then square root of 5 times square root of 5 is just 5. And so that would get rid of the square root. And so that would be our goal, is to figure out how to get rid of that square root. Okay, so that's conjugates. That's just vocabulary. So some products. This is something that you have to kind of think about. It's not something that I'm really going to force onto you for when you're doing problems or checking this or making sure that certain things are okay. If you remember, we had an absolute value rule in a section previously, and you do need to know that. So when the root is even, if once you take the root, you get any odd powers out of it, then what's going to end up happening is you have to make sure you put the absolute value around those. In this particular case, though, this doesn't have to do with absolute value. It just says that the nth root of a times b, we can split them up into the nth root of a times the nth root of b. Now, if n is even, and this can be true, this is true only if n is even and a and b are not equal to 0. So they can be negative, okay? They just can't be equal to 0. It is also true if n is odd. So if n is odd, I don't have to worry about a and b. If n is even, then a and b cannot be 0. Okay, rule. It's important to mention it. The book mentions it, but we really won't utilize that to do anything special with any of the products, multiplications. Quotient. So in the quotient rule, if I have the the nth root of a over b, that's going to be the nth root of a over the nth root of b. Notice I can split them up, plus I can go backwards the other way. And this is true for any a, as long as b is not equal to 0 and n is greater than 1. Now, the reason why these two kind of come into play is, of course, we can't have a denominator with 0 because that gives me an undefined or an infinite answer, depending on how you look at it. And this n greater than 1 just says the reason why n has to be greater than 1, if it was negative, then these two would flip, and then a couldn't be 0. So they're just saying kind of have to follow these rules. Any of the problems that you're getting are going to look like this anyway. Okay, so let's go to some problems. I'm going to do a couple first, and then we will go to the next video. But let me go ahead and do a couple to begin with. So here I have a cube root of -8 x cubed y to the 7th. So one rule that I just remember is that if this is an odd power, an odd root, and it's a negative, I know I can take a negative out. Okay, so I know that I can do that. If it was an even root and we had a negative, then I could not take a negative out, because remember, then we get imaginary numbers, and so we wouldn't be able to do that. But I can do that in this case. Now, how do I write this out? I have 2 times 2 times 2, and that's a cube root. And then I have times x times x times x, and then I have times y times y times y times y. That's 4 of them, 5, 6, and 7. So I have a bunch of y's there. Now, whenever we're doing, if you recall, with the square root, if I had two numbers that were the same under the square root, I could take one out. Well, with the cube root, if I have three numbers that are the same, 2, 2, and 2, I can take one out. Of course, negative's out there already. So that negative's out there already. That means these leave the cube root and it comes out. Notice I have another 3 x's. Take one out. Notice I have 1, 2, 3. I have a y. 1, 2, 3. I have another y. And then this y only has 1. Can't take it out. It's going to stay there. So I would have the cube root of y, because that's the only one that is left. Now I just have to clean this up a little bit. So I have negative 2xy squared cube root of y. Okay, so that would be my answer for that one. Okay, let's do one of your homework problems. So one of your homework problems says we have 18, a to the 6th, b to the 3rd, c to the 5. So notice here, this is a square root, so it means I need 2 of everything. But notice that I could split it up into these. This one I'm going to do a little differently just to show you a little different method. And so a couple things that I can kind of think about, at least, is I could write it like this. All to the 1/2 power. So I need to figure out how to split up the 18 into something that I can take the square root of. So 9 times 2, a to the 6th, b to the 3rd, c to the 5th, all to the 1/2 power. And of course, then, since all of these are multiplied together, and only because they're multiplied together, because remember with the rule, I cannot distribute a power if I have a plus or minus in there. But because these are all multiplied, I can distribute it. So it becomes, in this particular case, 9 to the 1/2, 2 to the 1/2, a to the 6 over 2, b to the 3 over 2, and c to the 5 over 2. And of course, we know 9 to the 1/2 power is 3. Okay? Times 2 to the 1/2, that does not change. Notice on the a, 6 divided by 2 is 3, so that just becomes a to the 3rd outside the square root. Notice with the b, though, 2 goes into 3 one time, so I can take out a b, and I have another b left over. And then on the c, 2 goes into 5 twice, so I can take out 2 c's, and then I still have 1 left over. Okay, so it would look like that. So kind of a mess in terms of writing it all out. You don't exactly have to do it exactly the way that I do it. But then what do we have out? We have a 3, an a cubed, a b, and a c squared. And then under the square root, we have a 2, we have a b, and we have a c. So we can see what we have under there. This would be my final reduced answer. So we'll go on to the next video and do some more examples.